Document databases. Document databases store information as flexible documents, usually in JSON-like formats. Instead of forcing data into rows and columns, they allow each document to have its own structure. This makes them useful for applications where data changes often or where different records need different fields. The rise of web applications helped popularize this model because developers could work with data in a format that closely matched programming languages. Document databases are known for balancing flexibility, performance, and ease of development. MongoDB. MongoDB is the most widely known document database. Created in the late 2000s, it was designed to handle large amounts of data while remaining easy for developers to use. Information is stored in collections of documents, and each document can contain nested data structures. MongoDB became popular among startups and large companies alike because it allows rapid development without requiring a rigid schema from the beginning. It is commonly used in content platforms, e-commerce systems, and modern web services. CouchDB. CouchDB is another document database, but it focuses heavily on reliability and synchronization. Developed as an open-source project, it stores documents and uses HTTP as a core part of its design. One of its distinctive features is the ability to synchronize data across multiple devices and locations. This makes it useful for applications that must continue working even when internet connectivity is limited. Firestore. Firestore is a cloud-native document database developed by Google. It is designed for mobile and web applications that need real-time updates. Data is stored as documents organized into collections, and changes can be pushed instantly to connected users. Developers often choose Firestore because it integrates closely with other cloud services and simplifies the process of building scalable applications. Key-value databases. Key-value databases are among the simplest forms of NoSQL databases. Every piece of information is stored as a value connected to a unique key. The database does not need to understand the content of the value. It only needs to retrieve it quickly when the matching key is requested. This simplicity allows extremely fast performance and easy horizontal scaling. Redis. Redis is one of the most popular key-value databases in the world. It stores data primarily in memory, making access exceptionally fast. Originally created to improve application performance, Redis is widely used for caching, session storage, message queues, and real-time analytics. Although it started as a simple key-value store, it later added support for more advanced data structures. Amazon DynamoDB. Amazon DynamoDB is a fully managed key-value and document database offered by Amazon. It was inspired by ideas introduced in Amazon's internal Dynamo system. The service automatically handles scaling, replication, and maintenance, allowing organizations to focus on applications rather than infrastructure. It is commonly used in large cloud-based systems that require predictable performance. Ryuk. Ryuk was designed around high availability and fault tolerance. The database can continue operating even when multiple servers fail, making it attractive for systems that cannot afford downtime. Its architecture was influenced by distributed computing research and helped demonstrate how large-scale NoSQL systems could remain resilient under difficult conditions. Wide-column databases. Wide-column databases organize information into rows and column families rather than traditional relational tables. They were created to handle enormous datasets spread across many machines. Unlike relational databases, different rows can contain different columns, providing flexibility while still supporting large-scale analytics and storage. Apache Cassandra. Apache Cassandra originated from work at Facebook. It was built to handle massive volumes of data across distributed servers without creating a single point of failure. Cassandra is known for high write performance and global scalability. Large organizations often use it for activity tracking, recommendation systems, and applications that generate continuous streams of information. Apache HBase. Apache HBase was inspired by Google's Bigtable system. Built on top of the Hadoop ecosystem, it provides scalable storage for huge datasets. HBase is commonly used when organizations need random, real-time access to data stored across large distributed environments. It became popular in industries dealing with big data processing and analytics. Google Bigtable. Google Bigtable is one of the most influential NoSQL databases ever created. Developed internally at Google, it introduced many ideas that later inspired other database technologies. Bigtable stores structured data across thousands of machines while maintaining high performance. Many large Google services have relied on this technology to manage vast amounts of information. Graph databases. Graph databases focus on relationships rather than records alone. Data is stored as nodes connected by edges, making it easy to represent networks of people, products, locations, or events. This model is especially useful when connections between data points are as important as the data itself. Neo4j is the best-known graph database. It was created to make relationship-heavy data easier to explore and analyze. Instead of joining tables repeatedly, developers can navigate directly through connected nodes. Neo4j is widely used in recommendation engines, fraud detection systems, social networks, and knowledge graphs. Amazon Neptune is a managed graph database service designed for highly connected data. It supports popular graph models and query languages while handling infrastructure automatically. Organizations use Neptune when they need to analyze complex relationships without managing their own graph database clusters. ArangoDB combines multiple database models within a single system. It can work as a document database, graph database, and key-value store at the same time. This flexibility allows developers to choose different approaches for different parts of an application without deploying separate database technologies. Time series databases are optimized for data that arrives with timestamps. They are designed to record measurements, events, and metrics over time. As connected devices, monitoring systems, and cloud services expanded, the need for specialized time series storage grew rapidly. InfluxDB was built specifically for storing and analyzing time-based information. It is commonly used for monitoring servers, collecting sensor data, and tracking performance metrics. The database includes features tailored to time series workloads, making it efficient for handling continuous streams of measurements. OpenTSDB was created to manage large-scale time series data on top of distributed storage systems. It became popular in organizations that needed to track infrastructure performance across thousands of machines. Its design emphasizes scalability and long-term data retention. Search databases are optimized for finding information quickly within large collections of text. Rather than focusing only on storage, they specialize in indexing and retrieving content efficiently. These systems became increasingly important as websites and applications grew in size. Elasticsearch is a distributed search and analytics engine built around fast indexing and querying. It allows users to search through massive datasets with near real-time performance. Organizations use it for website search, log analysis, security monitoring, and business intelligence. Its ability to combine search and analytics has made it one of the most widely adopted NoSQL technologies. Multi-model databases support more than one data model inside a single system. Instead of forcing developers to choose between document, graph, or key-value storage, they provide several approaches under one platform. This reflects a growing trend toward flexibility in modern data architecture. OrientDB combines graph and document database capabilities. It allows applications to store rich documents while also maintaining complex relationships between them. This dual approach can reduce the need for multiple database systems in a single project. Couchbase blends document storage, key-value access, caching, and distributed architecture. It was developed to provide high performance while maintaining flexibility. Many enterprises use Couchbase for customer-facing applications where speed and scalability are critical requirements. NoSQL-inspired NoSQL systems. Some modern databases borrow ideas from both traditional relational databases and NoSQL systems. They aim to provide strong consistency while maintaining the scalability that made NoSQL popular. These technologies emerged as organizations sought ways to handle massive workloads without sacrificing reliability. CockroachDB distributes data across multiple machines while maintaining strong consistency. Its design was influenced by large-scale cloud infrastructure and aims to survive hardware failures automatically. Although it supports SQL, many of its architectural ideas come from the distributed systems movement that helped shape NoSQL databases. ScyllaDB was created as a high-performance alternative inspired by Cassandra. It is designed to take advantage of modern hardware and deliver lower latency under heavy workloads. Organizations often adopt it when they need Cassandra-like scalability with greater efficiency. Vector databases are a newer category that gained prominence during the rise of artificial intelligence. Instead of storing traditional records alone, they specialize in storing numerical vector representations of data. These vectors allow systems to find similarities between images, documents, audio, and other content. Pinecone Pinecone is a managed vector database designed for AI applications. It enables rapid similarity searches across large collections of embeddings. Developers use it for recommendation systems, semantic search, and AI assistants that need to retrieve relevant information efficiently. Weaviate combines vector search with structured data storage. It was created to make AI-powered retrieval easier while supporting modern machine learning workflows. As large language models became more common, databases like Weaviate grew in importance because they help connect AI systems with external knowledge. Milvus. Milvus is an open-source vector database focused on large-scale similarity search. It can manage billions of vectors while maintaining efficient retrieval performance. Its popularity reflects the growing demand for databases built specifically for artificial intelligence and machine learning applications.